All right, so we want area, we want perimeter. And like I said, kind of the problem within the problem was figuring out how to deal with that right triangle that was a portion of the figure. So in that right triangle there, if I were to find, say, side Y, would side Y help me with the area or help me with the perimeter? Perimeter, because that was one of these pieces that was on the outside. Because I know how long this piece is. I know how long this one is. I know how long this one is. The information I got to figure out is a couple things. I got to figure out how long this piece is, and then I need to figure out what you said, and that was side Y. So let's see if we can figure out what side Y is. Well, remember we said we really want to look and see what do I have labeled. Do I have opposite? Do I have adjacent? Do I have hypotenuse? And I want to start usually with the angle they gave me. Well, they gave me this 20-degree angle. So if I use that 20-degree angle, I know this side is 6. Well, is that the opposite, the adjacent, or hypotenuse? Adjacent. You guys said I wanted to find out what Y is. Which one's that? Hypotenuse. So which one are we using if we're using adjacent hypotenuse? Cosine. So we're going to try to figure out Y by saying the cosine of 20 should equal that adjacent side of 6 over the hypotenuse that we're looking for, which is Y. And the way we've been attacking it is put this over 1 and cross multiplying. So eventually cosine of 20 times Y should equal 6. So I'm going to divide that to see what Y is. And now we let the calculator do the work. So 6 divided by the cosine of 20. Right. Should be about 6.38, 6.39. So we'll say 6.4. Everybody okay with 6.4? Mm-hmm. All right. So this side we now know is 6.4. Okay. Perimeter-wise, we got everything we need except this dotted line. Well, in order to find that dotted line, what do I have to know? Yeah, I got to know what X is, right? Because I know all the way across is 16, so I can take whatever X is out, and that would leave me with what I need. All right, so how are we going to find X? What are some options? Sure. Yeah, if I feel really good about this answer here, Pythagorean theorem would be an okay way of attacking. The only problem is if I made a mistake on Y, and then I use it, I'm going to make a mistake on X. So nothing wrong with it, but we always run that risk of making a double error. What if I want to avoid making a double error? Is there a way I can find X without using Y? Yeah, we could do tangent. We could say that with that 20 degrees, opposite is X, adjacent is 6, so we could use tangent for that one. So I'd say tangent of 20 would equal that X over the 6. And so this time when I cross multiply, I'll have my answer. And so that should have been about 2.18 to 2.2. So now I can label this with what would be left. So what is that, 13.8? And when we put it all together, that would be our perimeter. So what was our perimeter? 58, what's that? Perimeter should have been about 78.2. That was meters. Okay. All right, what about area? Do we have everything we need for area now? Yeah. Okay. Who can tell me what would be maybe one figure we deal with for area? Like what would you do? 16, 18. Yeah, 16, 18. So that was 288. The rectangle. What about for the triangle? What are we going to use for the triangle? Okay. Okay, so what would the base and height be in that picture? The base would be 2.2. Good. So I'm going to take the 2.2 we just found times the 6, divide by 2, and then we get 6.6. So when we put it together, we end up with about 294.6 square meters. All right. So that's an example of just kind of tying some things together, area perimeter with our trig ratios. All right, good. Let's say I gave you this situation here. In this situation, we have Mr. Gow, and he has to build this wheelchair ramp for the school's auditorium. And the ramp itself has to rise a total of 3 feet to get from the ground to the entrance of the building. In order to follow the state building code, however, he's got to make sure that when he builds that ramp, the angle from the ground cannot exceed 4.76 degrees. So he's got to get 3 feet up because that's where the door is, where the entrance is. But when he makes that angle, we got to make sure it doesn't go over 4.76. Well, here's his plan right now. Mr. Gow has plans from the planning department, and they call for the ramp that he's going to build to start 25 feet away from the building. Here's the question. Will this ramp meet the state building code? All right, so we know how high up we need to go. We know what his plans are as far as how long the ramp's going to be. Our question is it going to fit code? Is it going to fit that 4.76 degree limitation? So here's what I want you to start with. I want you to see if you can just sketch what the situation's talking about. And then I want you to have a discussion with people around you. We're not going to form our groups necessarily, but talk to people around you about, okay, how can we decide, is this going to work or not? Should I stick to the 25 feet, or do I need to change that plan? Because I can't change where the entrance is. It's got to be 3 feet no matter what. The only thing that can change is how long or how short I make the ramp, okay? All right, so sketch it first, and then talk to people around you, see if you have an idea of how we're going to figure this out. And in your discussion, compare your sketches. You know it's going to be a right triangle. Keep that in mind. There are your sketches. It doesn't have to be your group parts. Something to think about with your sketch before you go on from there. As I went around, a lot of you had that 3 feet. That was good because it was 3 feet off the ground. Where should the 25 go for X or for Y? So this is our ramp. Yeah, the ramp wouldn't get us very high, would it? We're going to need a ramp because we need to get up to that 3 foot mark. So your 25 is actually going to be. Oh, wait a second. Sorry. You're right. I read it wrong. I thought it said the ramp was 25 feet. It's 25 feet away. You're right. Sorry. Never mind. All right. I was thinking never said rent. So what would that mean? Well, better way to ask them, how should we change the situation?
You have to know it. Short.
That's kind of the next question about
You can do this, and this keeps that long. You can do this. Sure. You get to do this one less smooth.
if you feel like it's succeed, right, you're going to be that decrease in so that's why if you think about humble ambitions, you're slowly on the hill or something, or you still to the water. And it's straight up, right? Versus being able to start further away. So if you're going to decrease the angle, you're right with that speed.
Okay, so then you are fit. Say that to me.
So to start with, and then we're going to think about
How far you can get.
So you're saying that's how far away we should be? Well, that's saying we're exactly the same. Well, what I'm saying is that's when we want exactly 76 degrees. So we could make one as long as we were over the 76 degrees. If we wanted to decrease it even more. Okay, so that would tell you how long the ramp is. Would that help me out with your name? Because that's really all we're going to figure out. Is we need to figure out. We've already got the ramp there. We're not going to change the ramp. We got to figure out over time to place that ramp. Make sure it's still right.
The tangent of yours.
Maybe I'm already okay. Now we got to have that decision.
Now I'm doing the
I like to think right now, if you did that, you got 80.
I did.
So you're saying, okay, I know I had people below 4.76, so let's use
4 and see how far it goes. So I feel that, it's all right. Yeah, checks off needs code. Those sign of forms. Yeah, it needs code. I do a little bit. That's great.
Yes. So let's say. Oh, yeah. So yeah, close, so like you can see. I got this one.
I have a ladder right next to the wall.
We don't have to do that. Right, just do three sides at the end.
That's going exactly on.
Yeah, one.
Could I use an angle? I guess the question is, which of those two values could change, 3 or 1.5? So, let's say I decide I want to make it exactly. That would be my answer.
Did you get it right?
Maybe I could put that in. But you said this could change, maybe make that. See where, now see where. Now we need to put a 5, then you can see what you're checking. When you put something different, then you see accomplished. I like your idea, I don't like your visual. Yeah, this is your angle. Oh, you did, okay. So you were thinking about that. The ramp right now is already made. It's just a matter of feet put in place. So really the ramp would change. It's just how far away from the building. Really the only variable. I can't tell how high up it is. I could change how far away from the building. So use that idea, but try to find a bottom side. Okay. So would you do that? Right. We can, and this one's a little bit different because I didn't give you, in the picture at least, an angle. But one thing you can think about here is 2 parts of that triangle can never change. I can't change how high up it was to get in the building, and I've already made the ramp, so I can't change how long the ramp is. All I can do is change how far away from the building I'm going to put that ramp. So really, the 25 could change if I wanted to. So one way some people have been attacking it is they've said, okay, if that's code 4.76, I'm going to make that the equal bottom. So like they're putting 4.76 down there, right? And they're saying, well, I can't change this, but maybe I could change this. So they're making this their unknown, their X value. Which means when I look at this picture, if I know this angle, I have the opposite side, and I'm missing the adjacent side of this one next to it. And of these 3 options, one of these is opposite. So a possible equation I could use, it's not the only way to do it, but I could say the tangent of 4.76 equals the ratio of 3 over this missing value, or 3 over x. So you can write tan of 4.76 equals 3 over that missing X. What we talked about last week was, I'm gonna make this into a fraction, because then I can do some cross multiplying. So if I were to cross multiply, I've got tangent 4.76, which the calculator can actually tell me eventually, times X. And it's got to equal 1 times 3. So let's write that, tangent of 4.76 X equals 3. Well, if I want to get X by itself, I've got to divide by that. So ultimately, to get my answer, I'm going to do 3 divided by the tangent of 4.76. Okay, now I can type it. So if I do 3 divided by tangent 4.7. So right now, if I build it to code, I need at least 36 feet away from the building. So was he within code? No, because if I took that 36 and I moved it closer, that's going to make it steeper. It's just going to go up. Correct. That would be the way we'd have to do it to be exactly at code. Now we're going to look at another way to figure out, okay, what if I stuck with these two numbers? Could I see what angle is at already? And then we can figure out how to change it. Okay, but that might be a good strategy.
All right, so some different things here. We'll talk about the main strategy I saw.
You're smiling. Yeah.
So he was not within code because he had about 25. You're supposed to be 36.
Oh, you guys turned it off.
All right. Here was probably the number one strategy I saw. You knew what code had to be, 4.76. You knew you couldn't go over that, but there's nothing that says I can't equal that. So I saw a lot of you do this. You said, okay, well, I'm going to make this 4.76. Well, of those two measurements they gave us, one of those two measurements could vary a little bit. Which of the two measurements, the 3 or the 25, really could be changed?
25.
25, right? The ramp is already there. We built the ramp. We got it to the building. We can't change how long the ramp is, so I can't change how long the hypotenuse is. I can't change how high up the building is, but I can change where I put that ramp. So I can move it closer, I can change the angle on it. So some of you did this, you set up that picture. Those of you that set it up like this, what did you use? Sine, cosine, or tangent? Tangent. And when you did that, what did you get for your X value eventually?
Oh, 36.
Everybody else gets the same thing, roughly 36 feet?
Yeah.
All right, now answer the question, are they within code? Well, he put it at 25 feet. It was supposed to be at 36 feet. So was he within code?
No.
Well, it didn't match. Does that mean he's not within code? What would happen to this angle if I shortened up the distance?
It'll make it steep.
It's going to make it steeper. So you're right. It isn't within code because he took where it was and turned it this way, which means it had to have gotten steeper. If you think about a ladder up against a building, the closer you put the bottom of that ladder to the building, the more steep it's going to get. The further you put it away, the less steep it's going to get. So you're right. He wasn't within code. If he did want to build it within code, he had to have put it 36 feet away. 36 feet away is like 12 yards. 36 feet away, that's like 12 yards away. If I thought about going 12 yards away from the building with my ramp, I'd be out in the parking lot, wouldn't I? So what do they usually do with ramps to make sure that they're not too steep? What's that?
Make it longer.
Maybe make it longer, but I'm still going to end up further away, right? What are some other things that you do sometimes you see with frames? What? Yeah, you'll see it go up a little bit, it'll turn, go flat, and then it'll turn, go back up or backtrack, something like that. So instead of making one long ramp, they kind of break it up. Okay, so that was a good strategy for what we know right now. What if I didn't want to do all that work though and try to figure out, because right now we figured out what it was exactly at code, but that doesn't mean I have to be exactly at 4.76. Maybe I'm in a hurry, maybe I need to get this job done, and I don't want to measure out exactly to that. I just need a range to make sure that I can be within that range. Well, let's go back to original picture, original thoughts. Somehow it'd be nice to figure out what angle I'm at right now. We really haven't had a strategy for that yet. So here's how we're going to attack it if we're missing an angle. We're actually going to start out the same way we usually do. We're going to think about, well, what two sides am I given? Well, when I look at this picture, you already told me I had the opposite and adjacent. So really right now, this is the picture, or what it's showing. It's saying the tangent of whatever that angle is equal to 3 over 25. The question is, what's that angle? Well, we can find that angle on the calculator by thinking in reverse. So on your calculator, above the tangent button, it has tangent with a little -1. That's what's referred to as the inverse tangent. So anytime we're missing the angle, I can find it, if I'm using tangent at least, by hitting the second button, hitting tangent, and notice again that little -1 is with it, of the ratio that we had. Well, our ratio here was 3 over 25. And so when I do that, this is the answer I get, which means in that original picture, that angle was 6.84 degrees. So anytime I'm missing an angle, I can still use my ratios, but I'm going to do the inverse of those ratios to find the angle measure. So let's say I had this picture, and I wanted to find the missing angles. So I want to find out, well, what's the measure of A? What's the measure of B? And I looked at my picture, and all I have are two sides given to me. I don't have anything else other than that it's a right triangle. Well, if I decided I'm going to try to find angle A first, what two sides do I have in terms of opposite, adjacent, or hypotenuse?
You have adjacent and
Which means if I go to my list here, which one am I going to use?
cosine.
Cosine. So here's really what I'm looking at. I'm looking at the cosine of angle A, because the two sides I have are 14, which is the adjacent, over 15, which is the hypotenuse. So I go to my calculator and I do the inverse. I type in the inverse cosine of 14 over 15, and we see what angle measure I get. So if I do the inverse cosine of 14 over 15, get 21 degrees. And in most cases for angle measures, we're actually going to round it to the nearest whole number. So angle A would be 21 degrees. What about angle B? Well, do I have to go to sine or cosine or tangent here?
No.
No, we go back to what we knew already. We knew all three angles add up to 180. I've got two of them. And even more specifically, I know that these two add up to 90. So I should have my third angle by just doing that. Okay, so those would be our three angle measures. So anytime we're missing the angle, we're going to do the inverse, sine or cosine or tangent. Anytime that we have the angle measures, we just use the regular sine or cosine or tangent. So keeping those two things in mind, I'd like you to try those three problems. The first two, you're missing the angle measure. The third one, you're missing a side length. So think about all the strategies we've used so far. See if you can figure out what is missing in each picture. If you're missing the angle, let's go to the nearest whole number. If you're missing the side, go to one decimal place. Make sure you include your equations on it.
It's if you look at that angle, 12 is the opposite of it. It's actually adjacent to it, because it's right next to it. Which one uses adjacent, and that was right. So it's the same setup, but you use cosine instead of sine. And then you type it in again as your second.
And then you just invite them to, but in the right.
All right, if you would, let's move into your groups, compare those three answers that you got. Go ahead and scoot into your groups, if you would, please.
didn't think there was three. I'm like, I can't get myself this out of the big how do you do CD? Maybe a ramen.
7 over 1. And 7 over 1.
Could you go like opposite of the angle to the center?
Yeah.
The two sides to it. What'd you end up with on A? 60 degrees, right. Should have 60 degrees? No. That was a good inverse cosine problem. What about the second one? 45. Did I need tangent there? No. As soon as you recognized that it was 2/8 there, that told us that it had to be isosceles. So you could go straight to 45 if you want to on that one. Then the last one, we're missing the sides. Now we don't have to worry about inverses. What do you get when you divided 7 by the sine fixed? Everybody okay with that, 8.3? I didn't tell you. Always ask yourself, does that make sense? Well, 8.3 is a hypotenuse, and it's longer than the leg, so that's okay. If I got an answer that was shorter than 7, that would tell me I made a mistake somewhere. Okay, so always double check, make sure it makes sense. So those are really the two variations, missing angle, missing side. And hopefully we're getting pretty good with the sine, cosine, tangent recognition part. And the other day when we filled in our triangle toolkit, we filled in the front side, which is really only 4 options. But I mentioned we're going to have more options eventually. So we're going to kind of lead into 2 of our new options today. We won't necessarily get to those last 2 options, our next 2 options. But to help us get there, we need to review something that we've done in the past, but probably didn't do very much. All right, so what you're going to work on is being able to simplify a square root. So I tried to make a description there of one way you could attack simplifying square roots. First of all, I gave you a list of perfect squares. Okay, so 4 is a perfect square because that's 2 times 2. 9 is a perfect square because it's 3 times 3, and so on. So you have that list of perfect squares. Now, obviously, that goes on forever, so I didn't make a really long list, but I stopped at 11 squared. But when I'm asked to simplify a square root, for instance, the first one was the square root of 50. I'm going to ask myself, well, what's the largest number that is a perfect square that I can divide 50 by? So if I look through that list there, I find out, okay, well, 25 is the largest perfect square that I can divide 50. So I can break this down into 2 square roots. One of them being that 25. The other one being whatever I get when I take 50 divided by 25. Now, the reason I picked a perfect square is I know what the square root of 25 is. I know that's just a nice neat 5. The square root of 2 is not a perfect square, so I'm going to leave it alone. And this would be considered the simplified radical for the square root of 50.
So for each of those problems, you're going to go through and you're going to try to figure out, first of all, what's the biggest perfect square I can divide it by. Once you do that, you're going to go ahead and do that division and see if you can get it into a simplified square root. So work with your partners there and see if you can get the simplified form for all those square roots that are at the bottom. Like I said, this is going to help us lead into the next options that we have. So your first step is identifying what's the largest perfect square I can divide it by.
Okay, so you know, if you took 75 divided by 2, right, it's obviously not, like, because it comes out of decimal, right? Why is my house so That's not helpful.
Perfect square.
I'm like, I'm saying it should be. It's almost hit. Okay.
When you get that first initial 75, I ask myself, what's the biggest perfect square I have that I can Some of it maybe gets a bit, some of it may come back. You know, definitely people.
So, how do you find between these ones?
Not necessarily, but they're you may run it in some instances you can't divide it by two. That's what I got.
I don't understand.
So all I'm really doing is taking 75 divided by
See my biggest number. So my calculator is also stupid. Okay, so then.
What do you worry about square root?
Divided by 2. It would be 45.
There's some square model.
What if there isn't a square root of the square? Oh, then it doesn't work, right? So that doesn't work because it's not a perfect square, right? Okay, so number 1, 5, and 3.
Find the biggest one divided.
So 2 doesn't work for 90, so you have to go to 3. 30. And then.
That's why we're choosing for those squares.
The biggest square is 9.
That's where. Really? I didn't swear to 3.
But if that works.
It's a lot of times you. What you're doing is. You always want to get the biggest one possible though.
Because 4 times 4 is 63.
Yeah. Yeah.
And that's why you choose the perfect square, and then you choose the perfect square, and you choose the
Can I write it 11 2?
That's my goal, is I'm really pulling out any perfect square.
I got 11 4, so then that would be 2. I'm not all the way.
So far, so good on me.
You like very these are good. Okay.
The reason I'm having to do a lot of perfect squares.
There's this 25.
I want to go big if I can.
Okay. Yeah.
Sometimes it's hard to put all the way. Once you get one, you get
I'll show you why.
Then you drop down that. Okay, are you on 6? No matter what, you drop down. Yeah.
Try all.
Why do we cover my building?
Okay, I like your ideas here, but keep in mind, if I said, what's the square root of 9? Tell me.
Which one?
I'm sorry. You don't have to put the square root around it. It's just the number.
So might be like that.
Right. If I said the square root of 16, it's just going to be. And that's really why we're doing it. We're trying to get a nice number.
This is why I don't miss school. You can explain it some other time, but I just really do because I just finished. Didn't understand what the equation was.
We're talking about the first of all, supplementary angle back. So supplement would be 180 minus
Okay,
whatever.
that's more. I don't know the angle, so it would just be 180 minus
Or whatever.
Yeah.
Whatever they ask.
It's not easy for
Okay.
me.
Now they said that twice the supplement, so I'm gonna take that whole thing and double it. 3 is subtracted from it. Minus 3 equals.
And then you put the square root of what the answer is.
Okay, thank you.
We had to go through that, but I was confused.
Yeah.
All right, I think we're starting to catch on here to the simplifying part. I want to point out one thing here on why I told you to choose the biggest perfect square, though. Okay, so guys. This is one of the examples where choosing the biggest perfect square is going to save you some time. If I first go to my list here, I might notice that I can divide 48 by 4. And that's true. I could write it like this. What was another option we had, though, as far as perfect squares? 16 and 3. All right. If I really have it simplified, though, I should get the same answer. If I started with this here, I would now have 2 square roots of 12. If I went here, I'm going to have 4 square roots of 3. This is really the simplified form of it. Now, that doesn't mean I couldn't get there from that first method, though. Because if I looked at 12, and I divide 12 by something that's up here, 4. So I could actually write this one as that expression. 2 times the square root of 4 times the square root of 3. But the square root of 4 we know is nice and neat. That's really just 2. And 2 times 2 is 4. So I can still get there. It's just extra steps. So that's why it's best to go through your list and find the biggest one possible and use that one. Now, here's how why we did that. Here in a second, I'm going to come around to each group and I'm going to assign you 2 different values. One of the values is going to be a side length for a square. The other value is going to be a side length for an equilateral triangle. So I'm going to give you 2 different values. Again, one will be for the side of the square, one will be for the side of the equilateral triangle. Once you get that side length, here's what you're going to do with it. On the square, I want you to try to figure out what's the length of the diagonal. But when you find the length of the diagonal, I want you to write it in simplified square root form if it doesn't come out nice and neat. So I don't want any decimals for your answer here. I want it in the simplified square root form. So you're going to use the strategies we just did. So you're going to find the length of x and make sure it's in simplified square root form. Also, in your square, you're going to label any angles that are created by drawing that diagonal in. Okay, so there are 6 different angles there. You're going to label the measures of all 6 angles. All right, so that's what you're going to do with the square. When I give you the side length for the equilateral triangle, what I want you to find is the height of that equilateral triangle. Same thing though, make sure that you don't have any decimals. It needs to be in simplified square root form. Okay. Also, you're going to label all these angles. Okay, so counting the one I already labeled there, you have 6 again. So the measures of all the 6 angles. All right, so 2 different things you're going to have to worry about: the square and then the equilateral triangle. And then based on those results, we're going to put some displays together tomorrow and see how that helps us with a new strategy. Okay, so the first number I give you when I come around will be for the square. The second number I give you will be for the equilateral triangle. All right, so for this group, 1 for square, and 10 for the triangle. This group is 2 for the square. This would be 3 for the square, and 6. Or I use the 4 for the square. I'm giving you the side. Yeah, I'm giving you the side length for that. You get 5 for the square, 2 for the square.
And then. He's going to get good at this one day. This might be really good feature I could fit someplace. Well, like, what is
16.
square?
Again, the number I gave you is the side length. It's not the x of the h, it's the side length. So you got to come up with a strategy for figuring out that missing side, make sure it's simplified, and measure or mark the angles as well. When you think you have those measures, tell me and I'll look at them.
Those are the angles. And like,